Morning, children. Today we start the new topic, that is application of derivative. In the last section we had an applicable one assessment of the four chapters, that is inverse trigonometric function, matrices, determinant and differentiation. But certain extent it is okay, satisfactory, but for some 2-3 students the performance is not up to the mark. We have to prepare well. Now application of derivative as per because of the present situations of the COVID pandemic, some topic of the application of derivative is removed, that is the rate of change as well as the differential approximation. But the rate of, without mentioning the rate of change, we cannot go for further applications of this topic. So I just mentioned the brief meaning. Actually, the brief meaning of the derivative itself is the rate of change. When you consider a function, say y is equal to f of x, you know that x is the independent variable and y is the dependent variable. Rate of change of y with respect to x, that is what we mark it as dy by dx, and that is called the derivative. So that rate, the brief meaning of the derivative itself is the rate of change. So in other topics like that, physics and chemistry, you can see that suppose displacement is a function of time. Rate of change of displacement, that is a ds by dt, rate of change of displacement with respect to time, that is called the velocity. So this is one application where we can find the velocity by using the differentiation. And the velocity, if you mark it as v, the rate of change of velocity, dv by dt, rate of change of velocity with respect to time, and that is called the acceleration. So there also, for finding out the acceleration, we are using the differentiation. For finding the velocity also we are using the differentiations. And that is a basic application of the differentiation, where we use the rate of change. But as per the latest syllabus, this one, the rate of change is removed, as well as the differential approximation also removed. So let us come to the correct, what is required for the present year. That is one of the applications is increasing decreasing interval. How the differentiation helping us to find out the increasing and the decreasing interval. How we can use the differentiation to find out the increasing and decreasing interval. And before finding out that one, let us have an idea about what is an increasing function and what is a decreasing function. Increasing function. If I take a figure like this, say this is the graph of a function y is equal to f of x. Here you can see that when x increases, this is the corresponding y value. This is the corresponding y value of that function. The next corresponding, suppose if I take x is equal to 1, then f of 1. This is f of 1. When x is equal to, say, x is equal to 3 here, then this is f of 3. This value is f of 3. So when x increases, you can say that the y value, we call it y is equal to f of x, or the f of x value can be called as a y value of that function. So when x increases, the y value also increases. And such functions are called the increasing function. When x increases, the function's value is also increases, we call it as increasing functions. In general, if you want to have a correct definition of it, let I be an open interval. So we say that a function is an increasing function in the open interval I if for every x1 comma x2 belongs to I, for every x1 and x2 belongs to I, if f of x1 belongs to I with x1 less than x2, if it is implies f of x1 is also less than or equal to f of x2. For every element in the interval I with x1 less than x2, if it implies that f of x1 is less than or equal to f of x2, for all, this is simple for all x1 comma x2 belongs to I. For all x1 comma x2 belongs to I, then we call it as an increasing function, or another word is it is increasing function. Okay. Now, if x1 less than x2, if it implies that f of x1 is less than f of x2 for all x1 comma x2 belongs to I, then we call it as strictly increasing. Here you can see that f of x1 less than x2, if it implies f of x1 is less than f of x2, then we call it as strictly increasing. And here f of x1 is less than or equal to is none, we call it as increasing. Here we use the word increasing, here we use the word strictly increasing. So you can, in another way, if I say that when x increases, y also increases, then it is an increasing function. Now, strictly, I will just draw another figure where say it goes like this. This is not strictly increasing, this is increasing, I can say, because some stage it is the function is equal. Here also it is coming as equal. So y value is coming as equal. So this is the figure where it is showing this is strictly increasing, because whenever x increases, y also goes on increasing. Here, when x increases, sometimes y value is coming as equal only. So this is the figure for increasing, this is the figure for strictly increasing. Now what is about the decreasing? Decreasing is when x1 less than x2, if this implies f of x1 is greater than or equal to f of x2. Remember, x1 less than x2 implies f of x1 is less than or equal to f of x2, it is increasing. x1 less than x2 implies f of x1 is greater than or equal to f of x2, we call it as a decreasing function. It is decreasing. And the same way, x1 less than x2, if this implies f of x1 is greater than f of x2, we call it as a strictly decreasing. So, when x1 less than x2 implies f of x1 is greater than or equal, is x1 less than x2, function's value is greater, then it is called decreasing. And here it is strictly decreasing. So, let me ask a question like this. See, I just draw a 4 figure. This is figure 1, figure 2, figure 3, figure 4, and figure 5. Just like here, this is x variable and this is y variable. So x when increases like y value also it is increasing. So this is increasing, or you can say strictly increasing. Here x increases, this x and this increases. Y increases, but some stages it is coming as parallel, equal. So it is increasing. This is also increasing. And here you come, this is x and this is y. When x moves like this, x increases, you can see that the function is coming down. Function value is coming down. So it is decreasing. Or you can say strictly. And here you can see that see, when x increases, it is decreases, y also decreases, but some stages it is coming as equal. So it is decreasing. And see here, when x increases, y increases, but again still x increases, y decreases. So sometimes it increases, sometimes it decreases. So it is neither increasing nor decreasing. So we have 5 types: strictly increasing, strictly decreasing, neither increasing nor decreasing. Now my question is, now x, if I move from here to here, this side, when x decreases, what happens to the y value? I am moving from this direction. When x decreases, the y value also decreases. So that is also increasing only. So you should not have confused with the word decreasing alone. When x decreases, y also decreases, it is a non-increasing function. And here you see, if I move from like this, when x decreases, y increases. In the other direction, when you take x increases, y decreases. So it is a decreasing function. If you move from here to this side, so when x increases, x decreases, y increases. It is a decreasing function. So in general, we say like this: when x moves, y also moves in the same direction. Then it is a increasing function. This also increasing. X decreases, y decreases. These two both will give the increasing function. And the other case, when x increases, y decreases. Or when x decreases, y increases. That is a decreasing function. So you can, in brief, you can remember like that. If the movement of the variable both in the same direction, movement of the variables both in the same direction, they are increasing function. Is moving both ways. Movement of the variables are in the opposite direction. X increases, y decreases. X decreases, y increases. They are in the opposite direction. Then it is a decreasing function. So you have to remember the definition of increasing and decreasing function in an open interval like this. If you take any two element of that interval, say x1 and x2, and x1 is less than x2, function's value also less than equal to function's value of x2, then it is a increasing function. That is the definition of an increasing or decreasing function in a particular interval. Now, the definition of increasing and decreasing in a particular interval we have mentioned. Now, what about the one more definition as increasing and decreasing at a point? Let me take like increasing at a point. Say x1. So we have already the definition of an increasing function in an interval. What is the definition? Suppose I is the interval. If x1, x2 are two elements, f of x1 less than x2 implies f of x1 less than f of x2 for all x1, x2 belongs to I. This is the definition of a strictly increasing one. Okay. So increasing at an interval we are defined. Now it is the increasing function at a point. Say point is x naught. The definition comes like this: if you can get an interval I like this. Now this is an open interval now. And in this open interval, x1 is a point, x1 minus h and x0 plus h. That means an open interval is created which containing x0. x1 minus h, h is a small positive number, x0 plus h. Suppose if I take, say, I want to get x1 is equal to say 1. So I can have a 0.9 and 1.1 like that. So an open interval is created. In this open interval, function is increasing. We can say that it is increasing at this point. So the first definition was increasing of an on an interval. That definition is over. Now from that definition we come to the definition of increasing at a point. So with that point, if you can create an open interval like this, and in that open interval function is increasing, we can say that it is increasing at that point. So first part is increasing in an interval, and then second it becomes increasing at a point. So nothing to worry about that one, just you remember this definition. If it is following, it is an increasing. Okay. So the same for the point also, you have to create an open interval like this, and in that interval it should be increasing. So it is called increasing at a point. The same way decreasing at a point also can be defined. The same way, similar way also. So now we have a definition of increasing function and decreasing function, and strictly increasing and strictly decreasing. Now let us come to the point that how the differentiation is helpful for finding out the increasing interval and decreasing interval. Of course, this there is a property, or you can call it as a theorem. It says that if f is a real function means a real value function with on, and it is continuous on the closed interval AB and differentiable in the open interval AB, then if f is increasing, and then f dash x will be positive in that interval, and if it is decreasing, then f dash x will be negative in A. So what is the definition that comes? F is a real valued functions, and it is given that f is continuous in the closed interval, and it is differentiable into open interval. These two conditions are given. Given function is continuous and differentiable in the closed interval and open interval. Then to check the increasing or decreasing, we are going to use in this interval, that is, if f dash x is positive in the interval and f dash x is negative in the interval, f dash x is positive means this is increasing, and f dash x is negative means it is decreasing. So we have to check, we have to find out the derivative of the function and check whether derivative is positive in the open interval AB and derivative is negative in the open interval AB. If derivative is open and the derivative is positive in the interval, we say that it is increasing interval. If the derivative is negative in the interval, we say call it as a decreasing interval. And this is, we take it as without a proof. The reason is that this proof is based on the Lagrange's mean value theorem, and Lagrange's mean value theorem is also removed from the syllabus this year. So I am not going to go give a proof of this one. You have to remember these results. That is, so one of the application what we are going to use is find out derivative and check the derivative is positive in the interval. We call that interval is a increasing interval. If the derivative is negative in the interval, we call the interval is a decreasing interval. I just make it once again clear that what is the application of derivative in finding the decreasing and increasing interval. We will find out the derivative and check whether the derivative is positive. F dash x is positive or not. If f dash x is positive, the interval we said is increasing interval. If f dash x is negative, we call it as a decreasing interval. And sometimes f dash x will be equal to 0 if it is a constant. That you know, if constant derivative is a 0. This is of course the definition, but there are some working rule how easily we can get this interval, and that I will explain. So I just will repeat it again. You just find out the derivative and check for which interval f dash x is positive. We call that interval as an increasing interval. And next check the interval where f dash x is negative. We call it as a decreasing interval. Let us take one problem of solving it, and I will explain the method of working rule for it. Okay. Say you are given a function, say fx is equal to 4x minus 3. I want to find out it is a real valuing function, that is its domain is R. I want to find out the increasing interval or decreasing interval for this function. So as per the result, what we do is we find out f dash x. What is f dash x here? 4. Okay. Then f dash x is equal to 0 means 4 is equal to 0. We know that 4 cannot be equal to 0. So let me take another example. Say, let me change the example. Say 2x square minus 3 is the function. So if I find out f dash x is equal to 4x, then let me take here also, because this is 4x minus 3. Okay. So f dash x is equal to 4x minus 3. Right? Then f dash x is equal to, you have to find out the point where f dash x is coming as 0. So f dash x is equal to 0 if I take, I will get to 4x minus 3 is equal to 0, or 4x is equal to 3, or x is equal to 3 by 4. So x is equal to 3 by 4 is the point where f dash x is 0. So the one side, that means it changes the nature. This point we call it as a turning point. Right? So using this 3 by 4, we will be dividing the real number system, that is real numbers. That is minus infinity to 3 by 4 is 1, and 3 by 4 to infinity is the. So you have a number 0, and this is 1. 2, etc. Infinity will be there, and here minus infinity will be there. So when 3 by 4 is the point, it comes somewhere else here, 3 by 4. So minus infinity to 3 by 4 is the one interval, and 3 by 4 to infinity is the other interval. With this one point, that is one turning point, we get like this, minus infinity to 3 by 4 and 3 by 4. So in this, one will be decreasing interval and other one will be increasing interval, because this is the point where it changes the nature. That is why f dash x is equal to 0, we got it, and we equated and we got a turning point. Right. Now, which one is the increasing interval, which one is the decreasing interval, we have to check it. And for checking that one, let me take a point of this interval. What will be a point of this interval? Say 0. 0 is the point here. And let me say f dash 0. What is f dash 0? Here is f dash x. So f dash 0 is minus 2. Because when I put x is equal to 0, minus 2. So it is negative. That means this is in this interval f dash x is negative. So this is a decreasing interval. Okay. Now take a point of this interval. Say what is the point we can take? 1 we can take. 1 belongs to this interval. 1. So what is f dash 1? F dash 1 means 4 minus 3. That is equal to 1. It is a positive. So here f dash is positive. So it is an increasing interval. So this is the way we will be finding out the increasing interval and decreasing interval. So what is the working rule? This time I will explain like you. Okay. First step is we will be finding f dash x. Find f dash x. And second step is solve f dash x is equal to 0. You solve it. So solving that one you get a turning point. We call that what is the value of the x we get, we call it the turning point. Because it changes from increasing to decreasing like that. So that is why we call it the turning point. And then use this turning point and divide r into intervals. So if you have one turning point, you will have two intervals. If you have two intervals, you will have three intervals. Suppose if I have 0 and 1 are the two turning points. So minus infinity to 0, one interval will be there, and 0 to 1 another interval will be there, and 1 to infinity another interval will be there. So if one turning point means you will have two intervals. If two turning point means you will have three intervals, etc. So use the turning point and divide r into intervals, and then check the positive or negative of dy by dx. So if for each interval you take a point, any point of that interval you can take and check whether dy by dx or f dash x is, you can see f dash x, and check f dash x is positive or negative. So these are the some 5 steps you have to take. First find out f dash x, and then solve f dash x is equal to 0. Then whatever the value of x you get, we call it as turning point. And then use that turning point to divide the real numbers into different intervals. Then take each interval, take a point of this interval, find f dash is positive or negative. If f dash is positive at that interval, we call that interval is as increasing interval. If f dash is negative, we call it as a decreasing interval. So this is what the steps we have to follow for finding out the increasing or decreasing interval. I will share some of the questions of these examples, and you have to prepare for this one. Okay, thank you.